Hi, welcome back to Trigonometry, Chapter 6. We're going to do Section 2 this time. I'm going to do a little bit different for you guys. It's going to help you out. I decided not to do examples because obviously I can copy it and explain it and all that stuff. I'd rather just do the problems on page 304, which is Chapter 6, Section 2, Version 4 of this book, Charles P McKeague. I'm going to do problems 2, 6, 10, 14, 20. 24 is a little bit difficult. 26, 30, 34, 38, and 42. I'm going to tell you why I pre-selected these problems. You can use the stop button to get the rest of the problems done, and then hopefully it'll help you guys out a lot. So let's get started. Number 2. It says square root of 2. Square root of 2 times the cosecant of theta is equal to 2. You got a problem here. You don't know how to do the cosecants. So on all of these problems, I would change to sines and cosines if you can. That's the easiest way to solve this problem. So I have square root of 2 times 1 over sine of theta is equal to 2. From here, I'm going to bust that fraction, BTF. Bust that fraction. Most teachers call it fraction busters. I don't like that word. I'm going to bust that fraction. So since there's a fraction, common denominator sine theta, I'm going to multiply by sine of theta on the left side, multiply by sine of theta on the right side. We notice that the sine of theta and the denominator sine theta, because this is in the numerator, this is in the denominator, they cancel out. So on the left-hand side of the equation, I have radical 2 equals 2 sine of theta. So how do we solve for the sine theta? We divide it by 2. So the sine of theta is equal to radical 2 over 2. We know that that, by the way, FYI, is approximately 0.707. So it says solve for the theta between 0 and 360. So we know that theta is equal to theta hat is equal to 45 degrees because we used the reference angle. It's positive, which means it's going to give you that angle of 45 degrees. We also know the sine of theta is positive from using all students take calculus in quadrant 2, which means it's going to be 180 degrees minus 45, which is equal to 135 degrees. Those are your two answers. I can check it if I want. I'm not going to. We're going to go on. Sorry about that. Save a little bit of time here. Number 6. 4 cosine theta minus 3 secant theta is equal to 0. I have no idea how to solve this problem now. It's a little bit difficult. The reason why is because I have a cosine theta and secant theta. As I stated earlier, we're going to change all the secant, cosecant, tangent, cotangent to sines and cosines. So I know that that becomes 4 cosine of theta minus 3 over cosine of theta equals 0. Because that's 1 over cosine of theta and goes to the denominator right over there. I'm going to bust that fraction again. I'm going to multiply the left side by cosine of theta, each single term, cosine of theta. On the right side, I'm going to multiply by cosine of theta on the right side. So multiplying the left side by cosine of theta, multiplying the right side by cosine of theta, and which means I'm going to multiply each single term by cosine of theta. I get 4 cosine squared of theta. Cosine of theta times cosine of theta is cosine squared of theta. That cancels. Minus 3 equals 0 times cosine theta is 0. You got a cosine squared theta right over there. When it's awkward, there's no linear term. We're just going to move 3 over divided by 4. So we end up with cosine squared of theta is equal to 3 over 4. How do you solve for cosine theta? That's a little tricky. So because of the square, I'm going to square root the left side, square root the right side. On the left side of the equation, square and the square root cancel. They're inverse operation. Cosine theta And I know a lot of you is going to forget to do this. Put the plus or minus when you take the square root of both sides. You got to put the plus or minus. And then square root of 3 over 4, same thing as square root of 3 over the square root of 4, which is plus or minus root 3 over 2. I know that to be approximately 0.866. So let's rewrite it. Cosine of theta is equal to root 3 over 2 cosine of theta, or cosine of that angle, theta is equal to negative root 3 over 2. How do we find the angle theta? Theta hat is obviously 30 degrees. Oh, number 6, let's see. They want number 6 to be in degrees still. Okay, great. Which means that it's going to be 30 positive in the first quadrant. It's going to be positive in the fourth quadrant, which is going to be 360 minus 30. It's going to be 330 degrees. Those are your two solutions, this or this. One is equal to negative root 3 over 2. We know that the angle, the reference angle is 30 degrees again. One is negative this time. If you're not quite sure, to find theta hat, we take the absolute value of that. So cosine of that angle is equal to positive, just like this one. It's going to be the reference angle is 30. We know that from all students who take calculus, that the cosine is negative in quadrant 2 and quadrant 3. Okay, for the first one, we know it's positive in quadrant 1. All of them are positive, and cosine is positive. For this one right over here, it's 30 degrees. It's negative in quadrant 2 and 3. So you're going to go 180 minus 30, and for quadrant 3, it's going to be 180 plus 30. So 180 minus 30 is 150. And 180 plus 30 is 210 degrees. Again, 30 degrees, 330, 150, and 210. That answers that. This was a little bit rather difficult problem. Let's go to the next problem. On page, what number was that? That was number 6. I'm going to do number 10 now. Be persistent, work hard on these problems, and you should be able to do most of like the odd ones too as well. 2 times the sine of the angle theta plus sine of 2 theta is equal to 0. We got a problem, big problem. That's 2 theta right there. I believe it was in chapter 5. You should know that the sine of 2 theta, or the double angle, that's the double angle. Ooh, Mufasa. Kind of tricky. I'll give you a little bit of a hint on how to find the double angle. Sine of 2 theta is equal to, bring out the 2 right there, becomes 2 times the sine of theta, and I have to multiply by the cosine of theta. So you have to bring the 2 out to the front and just multiply by 2 cosine theta. That's the double angle. You should have that memorized from last chapter for the test anyways. So rememorize these. It's going to come out on your test. So I have 2 sine of theta, cosine of theta. Oh, sorry. That's the first term, 2 sine of theta, plus 2 sine of theta, cosine of theta, equals 0. So what do we do from here? I noticed that there's a sine of theta and a 2 for these two. Here's the first term. Here's the second term. I'm going to factor out 2 sine of theta. That's called factoring out, guys. So when I say factor out something, put whatever you factor out, put parentheses. Looking at the first term, because I have a plus here, that's the first term. I end up with 1. Drop the sign. I factor out a 2, a sine of theta. I end up with cosine of theta. Equals 0. Zip it out. 0 product property. We should know that from 6.1. We set each factor equal to 0. 2 sine of theta is equal to 0. and 1 plus cosine of theta is equal to 0. Solving for sine of theta equals, we divide it by 2, 0 divided by 2 is 0. Cosine of theta is equal to, we move the 1 over, it becomes negative 1. For what angle will it be 0? It's going to be, let's look at number 10, it's still in degrees. Okay, so 0 degrees and 180 degrees. 1 is equal to negative 1. Wait a second. Does that make sense? 1 is equal to negative 1. It's also at 180 degrees. Is that right? We got double. Let's make sure. Sine of 0 is 0 times cosine 0. Sine of 0 is 0 again. You get 0. That checked out. 2 times the sine of 180 is going to be 0. Plus sine of 2 times 180 is going to be 0. That seems to be right. Am I missing anything? I usually don't end up with two angles that are the same. That's interesting. 2 times sine theta plus 2 sine theta cosine theta is equal to 0. When I factor out 2 sine theta, I get 1 plus factor out this cosine theta equals 0. So each factor equals 0. Zip it out. Sine is equal to 0. At what angle? It's going to be 0 at 180 degrees because it's going to be the x direction. Cosine theta is equal to negative 1 at 180 degrees. Okay, I get 0 at 180 degrees. I don't need this again because that's the solution set. If I made a mistake, let me know. Nobody's perfect. I do not profess to be perfect. Let's do the next problem, which is number 14. I want it in radians this time, between 0 and 2 pi. Cosine of 2x minus cosine of x minus 2 is equal to 0. Again, we have a problem. The problem is very simple. It's the cosine of 2x. It's the double angle for the cosine. Ooh, fasa. Okay, so we have to remember what that was. There's 3 flavors for these. Cosine of 2x is equal to cosine squared of x minus sine squared of x is equal to 2. Cosine squared of x minus 1 is equal to 1 minus 2 sine squared of x. I'll show you an easy way to memorize these. It comes in 3 flavors. This is vanilla, this is strawberry, and this is chocolate. Ooh, look at that, Neapolitan. Easy way to remember is, if I put a plus right there, it's going to be the Pythagorean theorem. So just put a minus, that way that's the first equation for the cosine of 2x. 2 cosine squared of x, you just memorize that. Cosine squared comes first. C comes before S, so it's 2 cosine squared minus 1. The other one is flipped with the sign. It's going to be 1 minus 2 sine squared. Easy way to remember that, guys. So let's get started. Which one are we going to use? Are we going to use flavor vanilla, strawberry, or chocolate? Well, since this middle term is in cosine, I'm probably going to use this one. So let's rewrite it. I'm going to point to it as we go along. I'm going to replace it. 2 cosine squared of x minus 1, and then minus cosine of x minus